All right, this calculus lesson is a pretty easy one. It's on extrema, so it should be pretty fast here, you guys. So definitions, you guys, extremas, I'm sorry. If f prime of c equals 0 or f prime of c equals some number over 0, okay, so you set the numerator or the denominator or just the function, the derivative equal to 0, then c, when you solve for that, is called a critical number. C-R-I-T-I-C. Yeah, I think so. I think I spelled that right. Uh, okay, so anyways, I was just double checking my notes here. An extrema, which is a max or minimum value, is any endpoint, a Sharpie point, or a flat area of a function. And I'll show you in just a second. So types of extrema, endpoints, relative minimums or maximums, and that'll be in the next lesson, you guys. And absolute mins or absolute maxes, and that's what this lesson's all about, is the absolute. So for example, you guys, right here, this is an extrema because it's an endpoint. That's an extrema. Over here, that's an extrema because it's an endpoint. That's not an extrema because it keeps going up forever and ever and ever. All right, looks like on this function right here, considering these endpoints, this would be the absolute minimum. This would be the absolute maximum because that's the highest it goes. This would be what's called a relative max, and this would be a relative min. Over here, this would be the absolute minimum. This would be just it's a relative maximum, but it's a critical number right there. It's a relative max, and this would be what's called a relative min. All right, so anyways, so the procedure to find extrema, you find first the derivative of the function, then you solve for it equal to 0. Either if it's a fraction, then you set the numerator and denominator equal to 0. If it's not a fraction, then just set it equal to 0. And then I like doing a value chart and then including the endpoints, you guys, because the endpoints could be the relative maximum or the relative minimum right here, okay? Or not, sorry, the absolute max or the absolute min. So you set that up at the value chart and plug them into your original function, and then identify the absolute extrema, and then graph if you need to. Usually I don't need to, but that's optional. But you have the graphing calculators you can see really fast, okay? And note, it's possible to have more than one absolute extrema. Can you see I have two absolute maximums here? Okay, but in this lesson we're just going to identify the absolute extremas. We're not going to deal with, like, this would be the relative min, because over here it goes down forever, so there is no absolute minimum because it just keeps going down. Okay, and same on the other side. All right, so let's go ahead and find the absolute extrema in each. All right, so here's our function. So first find the derivative, set the derivative equal to 0, and you get the critical numbers when you set the derivative equal to 0, 0 and 1. So I'm going to include 0 and 1 with the two endpoints right here. So I'm going to make a table. All right, there's a chart, and I'm going to plug in all these x values. Notice I have the two 0 and 1 right here, and I have the endpoints negative 1 and 2. And I'm going to plug all of those back up into the original function, 3x to the fourth minus 4x cubed. And I've done that right here. And then so I can see this is the smallest it goes, this is the biggest it goes. So this is the absolute min, and this is the absolute max right here. And these are relative, I don't know, relative something. We'll talk about that in the next lesson. Okay, so that's all we're looking for right there, is the absolute mins and the absolute maxes right there. Okay, on this one, going to find the derivative. All right, there's the derivative, and then that's 2 over x to the positive 1/3, which is 2 over the cube root of x. Going to multiply this guy by, this is over 1, so I'm going to get the whole fraction, I'm going to multiply it by cube root of x over cube root of x to get common denominators, and so you get that. So now I'm going to set the top equal to 0 and the bottom equal to 0. And I get critical numbers x equal 1, x equals 0. So I'm going to make another chart including the endpoints right there and find out the absolute mins and the absolute maxes. Okay, so there we go. Absolute minimum is at -5. The absolute max is at 0 right there. All right, so that's it, you guys. So some books may want you to say that the endpoint is the absolute minimum, but so it just depends on your calculus book on that. Okay, so that's all you're doing on this. So there's your homework. The last two are going to ask you to work backwards on that. So anyways, nice easy lesson.